Hi friends, the last class we have already learned about the different types of errors and we have explained in detail also. And we have made a conclusion about the accuracy and precision. The accuracy of any measurement is related to systematic errors where its precision is related to random errors which includes the least count error also. So today what we are going to learn is the first one is the absolute error, mean absolute error, relative error, and finally the percentage error. So let's discuss all these things in detail. So first one is the absolute error. So just before that, just imagine you are taking or you are measuring a value, any value, you can take any physical quantity. You are measuring some physical quantity and a you will have an instrument. You maybe notice that while you are measuring the reading, it's not always coming, the readings are coming same. Sometimes it may be slight changes will happen there. Correct? Will never get an always a same value. It's very rare case. Most of the cases we will be getting a different value, slight change in the values. So this is coming under random errors. So among these value what you have measured, how you can identify or how you can say that which is the true value? It's very difficult, right? Because all the values are slight difference are there. So the better method is that take the arithmetic mean of all the values. What is that? Arithmetic mean of all the value, and that value we can treat as the true value because the true value is not given there. So just an example, the first one deal about the mean value or it is related to what the true value. Just imagine you are measuring a quantity, say it as A1. You have taken that quantity using an instrument and you got the value A1. Other time, second time you are getting A2, may be not equal to A1. And same way, just imagine all the values, there is a small changes are there. So A1, A2, A3, A4, etc. You have taken n values. Clear? So you will have an instrument, using that instrument you are measuring the value and each and every time you are getting slight changes are there due to some errors. Maybe due to personal error, some maybe due to the instrumental error, etc. So among this value, which is the true value? Can you say that which is a true value? Very difficult. So in order to get the true value or mean value, so I'm writing it as the mean value as a bar. Just a representation, mean value a bar, or you can write also a subscript mean value. A bar can be calculated as, which are the measured value here? A1 plus A2 plus A3 plus etc. AN. So we are going to find out the mean value. So divide by the number of times you have calculated a 1 2 3 4 etc. n, right? So you can find here this as taken as a bar, that is the mean value. And now we are going to consider this mean value is the true value in these measurements. So now let's discuss about the absolute error. What is that? Absolute error. So you can see the definition of absolute error here. It is the difference between true value and the measured value. What is that? It is a difference between true value and the measured value. So next one we are going to deal with the absolute error. What is that? Absolute error. So I can write here the absolute error, absolute error. We are representing the absolute error as delta A. What is that? Delta A. the absolute error. So first point is that what is the absolute error in the first measurement? The first measurement is here about A1. So I can write here the absolute error in the first measurement delta A1 is equal to, what is the definition we have discussed there? It is a difference between true value and the measured value. So we can write here true value. What is the true value we have treated as? That is the mean value, arithmetic mean here. A bar minus A1. The true value minus the measured value. We got the absolute error in the first measurement. Same way, next question is here, what is the absolute error in the second measurement? So I can note it down it as delta A2 is equal to A bar true value minus the measured value. The second one is what? A2. So you will get what? Absolute error in the second one. And you continue here, you will be getting delta A1, delta A2, etc., etc. What you will be getting the final one, that is the delta AN. What is that? Delta AN. So delta AN is equal to true value minus the last quantity, that is the measured value AN. So we got now the absolute error. Absolute error, it may be either positive or it may be negative also. Absolute error may be positive or it may be negative. There you are going to calculate here, if so, what is the mean absolute error? Next one is the mean absolute error. Mean absolute error. Okay, this is the mean absolute error. The mean absolute error, we can denote it as delta A bar. Delta A bar. Mean absolute error delta A bar is equal to. So as we already discussed here, the absolute error either positive or negative. But to calculate the mean absolute error, we will be taking only the positive value. So in order to represent that one, we are using the modulus. That means we are not taking the negative value, only the positive value. So you can write here delta A bar is equal to delta A1, the absolute error in the first measurement, plus modulus delta A2, absolute error in the second measurement, plus etc. modulus delta AN. What is that? Delta AN. That is the sum of all the absolute error to the total number. How many times you are taking here? That is the n times you are measuring the quantities, right? So all the errors, that arithmetic mean of this all absolute error, and that is called what? Mean absolute error. So I hope it is clear. Mean absolute error. So you can write here the mean absolute error delta A bar can be represented mathematically 1 by n. N can be taken as a common one outside. Sigma means here what? Summation means you are just adding all the values. So sigma I is equal to 1 to n modulus delta AI. This is a mathematical representation of mean absolute error. What is the meaning here? 1 by n, I equal to 1 to n. If I substitute I equal to 1, so it becomes what? Delta A1. This symbol represents what? Plus, addition of all these values. Plus, what is I next to value? 2. So delta A2. Next one, after 2, 3. So delta A3 plus etc. So you will be getting what? Same value. So this is a mathematical representation of what? Mean absolute error. Okay. The next one we are going to deal with, that is the relative error. What is that? Relative error. What is meant by relative error? Relative error is the ratio of mean absolute error to the true value. Here, what is the true value here? That is a mean value. You can write here, this is a mean value. True value can be treated as what? The mean value, or mean value can be treated as what? True value. So what is relative error? Definition once again, it is the ratio of mean absolute error to the mean value. So what is the mean value? We have denoted as a bar. So again, write this equation as mean absolute error delta a bar to the true value is what? A bar. So this is called what? Relative error. What is that? The relative error. Now let's discuss about the last one is called what? Percentage error. What is that? Percentage error. What is meant by percentage error? It's nothing but delta a bar divided by a bar, that is the ratio of mean absolute error to the true value, that is relative error, into 100. So you will be getting what? This is the delta a bar. Okay. So delta a bar divided by a bar, that is relative error. Relative error into 100 is called what? Percentage error. Okay. So now let's do a problem. So it will be very easy to understand. Let's do your NCERT problem itself, that is simple pendulum question. Okay. Let's do that one. Now let's do this problem. Read the question. We measure the period of oscillation simple pendulum. In successive measurement, the readings are given the, what are the readings are given the? 2.63 second, 2.56 second, 2.42 second, 2.71 second, and the last one 2.80 second. What do you have to calculate here? True value you have to calculate, mean absolute error you have to calculate, relative error you have to calculate, and the percentage error you have to calculate. So let's do this problem. What are the values given there in this question? So the values given there what? 2.63 second, 2.56 second, 2.42 second, 2.71 second, and the last one 2.80 second. These are the 5 readings which is given there. That means a person is measured using one instrument. So you can see here what is the least count of this instrument. You can see here 0.01 second is the least count of the instrument which the person is used here. Now the first one you have to calculate here the true value, or what is the mean value. So you can easily calculate here the mean value. T bar is equal to, what do you have to calculate? The mean value. Add all the values divided by number of readings, right? That is the arithmetic mean of all the measurements. So 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 divided by how many times? 1, 2, 3, 4, 5. 5 readings divided by 5. So if you do this calculation, you can do the calculation. What we are getting, just check the answer. So you are getting the approximately 13.12 is a total value divided by 5. So if you do this calculation, you will be getting the 2.624 second. So all the values there, you can see the 2 decimal places. You can write this answer in 2 decimal places as 2.62 second. Now you got the true value. What we are treating as the true value is the mean value. Now you have to measure absolute error in each measurement. So I can write here delta T1, absolute error in the first measurement, is equal to what? The true value 2.62 minus the measured value. What is the measured value? 2.63. And the next value you can write the delta T2 is equal to 2.62 minus 2.56, the next value. Absolute error in the third measurement is equal to 2.62, true value minus the given value is here 2.42. Same way delta T4 is equal to 2.62 minus 2.71. And the last value delta T5 is equal to 2.62 minus 2.80. Now you find what is the absolute error in each value. So you have to calculate and measure the value. As you already know, absolute error may be either positive or negative. So what is the first value? You can see here minus 0.01 second. Same way you write all the values. So now you got the values delta T1, the absolute error in first one minus 0.01 second. Second one plus 0.06 second. Third one 0.20 plus value. Next one minus 0.09, 2.62 minus 2.71. Next value minus 0.18 second. Next one you have to calculate here mean absolute error. How to calculate the mean absolute error? That is delta t bar is equal to, how to calculate the mean absolute error? That is, you have to add all the positive values. So don't take the minus because we have already discussed here, only take the magnitude. I mean the positive value. So 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 all divided by 5, you will be getting what? Delta t bar. What is that? Delta t bar. So do this calculation and what you are getting is getting approximately 0.108 second. We can write in two decimal places as 0.11 second. Now you got the mean absolute error. What is next one? Relative error. What is relative error? It's a ratio of mean absolute error in the measurement to the true value or mean value. We have taken as t bar. That is equal to 0.11 divided by, what is the true value? 2.62. 2.62. Calculate the value, what you are getting? Approximately 0.041 something. This is the ratio you are getting. No unit are the, cancels, the units cancel. Now, what is the percentage error? So, what is the formula for percentage error? Delta t bar divided by t bar into 100. So what is the answer here? 0.04, leave the 1 here, you can approximately write it as two decimal places. 0.04 into 100 is equal to 4%. So what is the percentage error in this measurements? That is the 4%. So we can write the value in terms of absolute error. In terms of absolute error, the actual value is written as 2.6. What is our actual value? 2.62. 2.62 plus or minus 0.11 second. This is a way to write the error with error and the mean value. You can write this value in terms of percentage. So what you can write here in terms of percentage? 2.62 plus or minus 4% in second. So this is the way to write this value or the quoted value here. Okay. So I hope it is clear how to do the mean value, then find the absolute error in each measurement, then you find the mean absolute error and find the ratio of mean absolute error to the true value, and into 100 you will get what? The percentage error. Hope it is clear. Thank you all of you.